Hey everyone, and welcome back to the channel. Today, we're diving into a super fun and easy science experiment that you can do right at home. We're going to build our very own mini balloon-powered boat. How cool is that? This project is perfect for a rainy day, a school project, or just whenever you're feeling a little bit curious. We'll be exploring some really neat scientific principles like propulsion and even one of the most famous laws in physics. And the best part, you probably have everything you need lying around the house already. So are you ready to become a master boat builder and a scientist all at once? Let's get started. First things first, let's gather our materials. It's a super short list, I promise. You will need a small, lightweight container to act as the hull of our boat. Something like a plastic food container, an empty yogurt cup, or even a small milk or juice carton works perfectly. The key here is that it needs to be waterproof and able to float. Next, you'll need a regular drinking straw. A bendy straw is great, but a straight one will work just fine too. Then grab a balloon. Any standard party balloon will do the trick. And finally, you'll need some waterproof tape. Strong packing tape or electrical tape is ideal because it holds up well in water. And that's it, a container, a straw, a balloon, and some tape. Oh, and you lines also need a pair of scissors and a body of water to test our boat in, like a bathtub, a sink, or a large plastic bin. Alright, let's get building. This is the fun part. Take your small container, which will be our boat. We need to make a small hole for our straw to pass through. Carefully, and maybe with some help from an adult if you're using something sharp, poke a small hole in one of the shorter sides of the container. The hole should be near the bottom, but not so low that it's completely underwater when the boat floats. It should be just big enough for the straw to fit through snugly. A little snug is good because it helps create a better seal later on. Now, take your straw and carefully thread it through the hole you just made. You want most of the straw to be inside the container, with just an inch or two sticking out the back. If you're using a bendy straw, position it so the bendy part is inside the container, pointing upwards. This will make it easier to attach and inflate the balloon. If your straw is straight, just make sure enough is sticking up inside so you can easily work with it. Let's make sure it's secure. Next up, it's time to attach our engine, the balloon. Take your balloon and stretch the opening a little bit. Then carefully slide the opening of the balloon over the end of the straw that's inside the boat. You want to slide it on about an inch or so to make sure it's secure. This is where the magic connection happens. The air will travel from the balloon, down the straw, and out the back of the boat. To make sure we don't have any air or water leaks, we need to seal everything up with our waterproof tape. Wrap the tape securely around the point where the balloon meets the straw. Make sure it's completely sealed so no air can escape from this connection. Then use more tape to seal the area around the straw where it goes through the hole in the container, both on the inside and the outside. We want to create an airtight and watertight seal. This step is super important for our boat to work properly, so take your time and do a good job. Your boat should now have a balloon attached to a straw that leads out the back. Okay, moment of truth. Our mini balloon-powered boat is officially built. Now it's time to see it in action. Let's head over to our ocean, the bathtub, sink, or water bin. Before we launch it, we need to fuel up our engine. Gently hold the boat and blow into the end of the straw that's sticking out the back. You'll see the balloon inside the boat start to inflate. Keep blowing until the balloon is nice and full of air. Be careful not to pop it. Once your balloon is full, pinch the end of the straw with your fingers to keep the air from escaping. Now for the launch. Carefully place your boat into the water. Make sure it's floating nicely. Are you ready? On the count of 3, let your fingers go and release the straw. 1 3 go. Wow, look at it go. The boat shoots across the water. Isn't that amazing? As the air rushes out of the balloon and through the straw, it pushes the boat forward. You've just witnessed a perfect example of propulsion. Let's try it again. Blow up the balloon, pinch the straw, place it in the water, and let it go. It's so much fun to watch it zoom around. So, what's the science behind our amazing little boat? It all comes down to one of the most fundamental laws of physics, Newton's third law of motion. You might have heard of it before. For every action, there is an equal and opposite reaction. In our boat, the action is the air rushing out of the straw in one direction backwards. The reaction is the boat being pushed in the opposite direction forwards. The force of the escaping air pushes against the water, propelling the boat. It's the same basic principle that powers real jet skis and even rockets. The rocket expels hot gas downwards that as the action and the rocket is thrust upwards into space that as the reaction. Our simple little boat is a perfect demonstration of this powerful law. Now that you've built a successful boat, it's time to experiment. This is what being a scientist is all about. What do you think would happen if we changed some things? Let's form a hypothesis. For example, what if we use a bigger balloon? Do you think the boat will go faster or maybe travel for a longer time? Let's try it out. Find a larger balloon, attach it to your boat in the same way, blow it up, and launch it. Observe what happens. Does it go faster? Does it go further? Here's another idea for an experiment. What happens if you change the shape of your boat? Maybe try a longer, thinner container, like a plastic water bottle cut in half lengthwise. Does a sleeker, more streamlined boat move through the water more easily? This relates to the concept of drag. Or what if you try a wider, flatter boat? Build a few different models and have a race. See which design is the fastest. You can also experiment with the straw. What if you use a wider straw, like one for bubble tea? Will that let the air out faster and give the boat a bigger initial burst of speed? Or what if you use two straws instead of one? Double the exhaust, double the power. You'll have to build it to find out. Keep a notebook and jot down your observations for each modification. This is exactly how engineers and designers improve their inventions. They build a prototype, they test it, they observe, and then they make changes to improve it. This project is so versatile. You can have races with friends and family. Set up a starting line and a finish line in the bathtub and see whose boat can make it there first. You could even create an obstacle course with some floating bath toys and see if you can navigate your boat through it. The possibilities are endless, and you're learning about physics while you play. Building this balloon-powered boat isn't just a fun craft. It's a hands-on lesson in science and engineering. You've learned about propulsion, Newton's third law, and the importance of design and testing. You've become an inventor, and the best part is that you did it with simple, everyday items. It just goes to show that science is all around us, in everything we do. I hope you had as much fun building and testing your boat as I did. It's amazing to see a scientific principle come to life in such a simple and exciting way. If you build your own boat, I would love to see it. Share photos or videos of your creations and your experiments. Let me know what designs worked best for you. Which boat was the fastest? What modifications did you make? Thank you so much for joining me today for this awesome science adventure. If you enjoyed this project, be sure to hit that like button and subscribe to the channel for more fun experiments and DIY builds. We're always exploring, creating, and learning new things together. Until next time, stay curious, keep experimenting, and have fun. Bye everyone.